In one of the fastest growing cities in the world, a love affair is blooming. Melbourne's residents are talking to their trees. A conversation is unfurling.
Dear 1517, I am confessing something very dear to me. I have fallen in love with 1583. Should I leave? Or should I stay? It would be great if you could give me some advice.
Around the world, more people are living in cities than ever before.
How's it going, 1517? I've been wondering, what's the city like for you?
If we change our perspective, we can see that trees are nature's great connectors. When trees breathe, so do we. Each breath cleaning the air and restoring balance. Our past, present and future are intertwined with trees, yet we have lost the ability to see them. To thrive, we must fall in love again with our city's trees and nurture our urban forests.
Hello, 1517. We don't have a lot in common, you being a tree and all. I'm glad we're in this together. Regards, a tree lover.
Hello, tree. It's your mother. How come you never call?
Hello and Happy New Year, everyone. Welcome to this week's news and community spotlights. Have you heard of the Launch Everywhere with Epic program? As of January 1st and onwards, we are offering a royalty rate reduction from 5 to 3.5% on all platforms and stores for eligible Unreal Engine games published on the Epic Games Store. You are considered eligible for this rate reduction if you ship your game on the Epic Games Store before or at the same time you release it on other stores on corresponding platforms you support. So things like PC, Mac, Android, and in the future, iOS. And in case you were wondering, this is also inclusive of games participating in Epic First Run. The royalty reduction will apply for all platforms and stores where you offer your games, including consoles. The royalty rate will revert to 5% if you offer your Unreal Engine game on another PC or Android store and do not offer it on the Epic Games Store for the corresponding platform. If you've been working on a game using Unreal Engine, this is definitely something to consider. And if you're still shopping around for the engine that works best for you, this could be an option to factor into that end decision. You can learn more about the program from the original announcement in the 2024 Unreal Fest Seattle opening or in our listed FAQs. Have you been looking for more ways to explore the procedural content generation framework tools? Well, you're in luck. we've recently released the Stellar Cassini sample. In this sample, you'll find a modular space station built using shape grammar, along with many of the newer PCG features, including pathfinding and raycasts. There's also a sci-fi device built using geometry processing and spline meshes, and the rings of Saturn have been created using GPU compute and GPU scene instancing. If you attended Unreal Fest Seattle, you may recognize the sample's cosmic environment from the session PCG Advanced Topics and New Features in UE 5.5, and it's now available for you to launch into and explore where no developer has explored before. You can download the sample from Fab now. Interested in meeting some of your fellow developers? Here's a list of community meetups happening this month. Find one near you and enjoy. It may be a new year, but one thing has definitely stayed the same: the level of creativity and quality that our community brings to the table. Let's explore this week's Community Spotlights. Cloud Bluffs by Corey Billette is a beautiful landscape scene created using a blend of Unreal Engine 5, the Substance Suite, and modeling softwares. It depicts a serene environment based off the equally stunning concept by Simon Brewer. It's a great combination of both familiar and a little alien, making us feel like we're exploring a vast corner of the universe that could still be a little bit like home. What do you think? You can check out the original post on their ArtStation. Real-Time Strand Hair by Eric Moaja had to be included. Just look at how incredible that hair looks. They created a blockout sculpt in ZBrush, which was then turned into curves that served as the baseline for XGen guides, leaving us with this result that was ultimately rendered in UE5. It looks so real, it's unreal. Make sure to give this artist some love on their original post, which includes a bit of a breakdown on the process and some amazing close-ups where all that detail work really shines. You can find it on their ArtStation. Taboda by Sky Graphics Studio is an incredible environment pieced together in Unreal Engine 5 using Kitbash 3D's Cargo Pro. They created a perfectly dense atmosphere that transported us straight to cluttered metropolitan streets that feel like danger and adventure lurk around every corner in equal measure. It's a scene that masterfully blends different genres into a world we want to explore more of and complete every single side quest along the way. You can see more of the project or their other work on their ArtStation. That's it for today's news and community spotlights. Thank you so much for watching, and we'll see you next time. Hello, everybody, and welcome back to Inside Unreal, a weekly show where we learn, explore, and celebrate everything Unreal. I'm your host, Tina, and today with me, I have some very wonderful guests who are going to be going over the latest updates to the Game Animation Sample Project. We'll go ahead and drop the link to that project in the chat for you now, in case you're unfamiliar with it and you want to check it out. But we're gonna get into it. We're gonna dive into it. Happy New Year, everyone. Good to see you back. To start us off, Caleb, let's start with you. Why don't you tell us a little bit about yourself?
Hey, I'm Caleb Longmire. I'm a senior animation technical designer on the animation gameplay team here at Epic. I work on a wide variety of projects, but as recently I've been focusing heavily on the game animation sample, which we're talking about today. That's yeah.
Yes. Yeah, very excited to have you here. Thank you so much for the time. Next up, we have Jose. Would you like to tell us a little bit about yourself as well?
Sure. Hey, I'm Jose Villarruel. I am the lead animation programmer of the animation gameplay team on Unreal Engine. Started my games career in the forums, participating in like game jams and whatnot back when UE was paid. And now I work on the game animation sample, pose warping, motion matching, and other sample projects.
Awesome. Pleasure to have you here as well. Next up, we have Tony. Tony, why don't you introduce yourself to the people as well?
Sure thing. Hi, name is Tony Gialdini. I'm the principal animator on the animation gameplay team. More recently, I worked on a lot of the animations that you'll see in the gameplay animation sample, but I help out all around on the Unreal Engine, helping with various teams. Most recently, I helped out the Fortnite team get motion matching into Fortnite. And yeah, now I'm working on gameplay animation sample content and making sure to feed the beast that is Caleb.
A job that someone has to have.
He always does
If
this.
they-
I
I'm
cannot
not
be
mean.
stopped. He's actually very,
Wonderful.
very, very nice. He's actually the nicest person, which is the only reason I pick on him.
It's wonderful to have you here as well, Tony. And last but certainly not least, we have Ludovic. Do you want to tell us a little bit about yourself as well?
Hey, yeah, I'm Ludovic Chaval. Most people call me Ludo, just like the friendly monster in the beloved movie Labyrinth. And I am technically part of the animation team, but I work on a sequencer and camera, so I'm part of it's the part of the animation team that was sent to boarding school and that you only see on Christmas. So I'll be talking about the second half of my job, the gameplay cameras that is actually in use in the newest version of the game animation sample.
Awesome. Very excited to go over all of this with y'all. Thank you so much for taking the time to chat with us today. For those of you watching, in case you're unfamiliar with the show, we will also be answering questions from you live. So we'll have a dedicated Q&A section at the end of the show after we're done going through all the updates and all the good stuff with the project. So if you have questions throughout, make sure you pop them in chat. We'll gather them into a nice list. We'll go through them, answer as many as we can. But yeah, so make sure you're popping your questions in chat throughout. So Caleb, I'll hand it back to you. Why don't you start us off?
You got it. Well, let's dive into the project. Actually, I think my screen is sharing. There we go. Welcome to the game animation sample. I'm just going to drop in real quickly and go over some of the updates and changes. One of the main things that we've added is we've finished our crouch animation set, so the character can crouch. And we have all the animations, just like walking and running, for crouch as well. Another thing is we have sprinting. It's a new thing that we weren't able to squeeze in last time, but we got it in and finished it for this update. So that really expands, what the character is able to do and sort of give you a great foundation for most third-person adventure games where you need to crouch and sprint. Another big update is the new gameplay camera system, which Ludo is going to be talking about a little bit later, and that is a completely new gameplay camera framework. I'll let him get into the details, but that can be enabled. It's enabled by default, but here in our widget, you can turn that on and off. And if you restart Pi, it'll change the camera system to the old system. So that's really cool. It's great to demo these, some of these new technologies. Another thing that we added is we have a state machine setup alongside the motion matching setup. And if I enable this, along with the debug draws, now the character is being controlled in a much more traditional way with a state machine. There are some caveats, and we're going to get into a live demo later in the stream where I'm going to break down exactly how that was built. But the state machine character can do all the things that the motion matching character can do, but it's using a lot less animations. And we have a new demo character down here that we can enable in the widget. The blue character is using a state machine. The orange character is using motion matching. Well, they're technically both using motion matching, but in different ways. And you can see that there's a good amount of parity between the two different characters with a lot less animations on the state machine version. So that's pretty cool. The other thing that we did, which was exciting, is we expanded the traversal system a little bit to include ledge catches. And we have a new obstacle course over here. So now we can jump, and if we hold the space bar, we can catch ledges to jump over them. So that's really fun. And parts of the traversal system were reworked a little bit, more reliance on choosers to make selections. And then finally, networking is all working in the project as well. And so this is network ready for multiplayer. As far as features, I think that's it. Jose, let me know if I missed anything.
That's the overall ones,
Yeah.
but I also wanted to show some of the new ones. So
Yeah. So I'll pass it over to Jose, and he can talk about some extra cool things as well.
okay, excellent. There's two main features that I wanted to talk about on the game animation sample 5.5 that one of them has been around for a while, but we've improved it for the 5.5 release, and that one is foot placement. As you might have noticed, there's this nice green hill on the side of the map, and that's because we now support slope warping, slope alignment using the foot placement node. If you see here on the right, there's a debug button for foot placement, so you can see exactly what's going on, which is the ground alignment. And it's a node that does other things than just aligning the feet to the ground. For example, it figures out proper hip position based on whether you're crouching or standing up. It calculates like what is the ideal leg extension for the character, and it either like raises the hip or lowers the hip. The other thing that I didn't see I saw that the community was talking about this one, but I didn't see a video on foot locking specifically. If you see those red dots at the bottom, and I walk around, you'll see that sometimes they become red, sometimes they're green. When they're red, it means that the feet locked into place because it detected that the feet are not moving the source animation, and to prevent sliding because of blends, because the character's motion is not matching the animation very well, it just keeps it in place to prevent sliding. So let me just record this over on Rewind Debugger. And there we go. Let me just walk backwards a little bit. There. Let me select the character. One thing that we did with foot placement on this release is that we improved debug drawing, and now it's compatible with Rewind Debugger. So you can scrub around and see exactly what is going on. So you'll see here my feet lock, and blue is where the animation would have wanted the feet to be, but because that's where the foot planted when we were at the point in animation where it was in contact with the ground, the foot stays there using IK. It looks, it's very minimal, like that smaller circle that you see next to it, it's the radius that we allow this locking to modify the source pose by. But if I disable it, you'll see how silly it looks on walk specifically when I don't have it. So let me just very quickly modify my animation graph so you can see it live. Here I'm just giving it a minimal weight so that the debug still shows when I'm moving around. And here you can see that the feet slide a lot when I'm doing these motions. But if I enable it, you'll see that it's a lot more resistant to these kind of motions like spam and whatnot. It just looks a lot better when you're using foot placement. Now let me go a little bit over the settings that you would use when you're going on a slope. Here we go. So when you're using foot placement, the main things that you want to do is fill out these entries. Like there's manual and graph mode. Graph mode is not very good right now, so just use manual. Fill out your bones that match your skeleton hierarchy over here. Under pelvis, just fill out the pelvis. I'll go over pelvis settings maybe later, but leg definitions, just assign them, and it's important for the algorithm that you apply, that you select what your ball bone is on the tip of the feet. But the next most important thing here is foot speed curves. That is something that we've added automatically through modifiers on your animations, but I'll show a little bit of that. So right here, you'll see that we have these curves, foot speed L and foot speed R, that represent the speed of the foot at that point in the animation. So basically, the logic of foot placement for foot locking is fairly straightforward. When it's lower than a certain speed in the source animation, it just locks the feet. And when it's higher than a certain threshold, it just unlocks the feet. These ones are auto-applied with an animation modifier. You can see those right here. These are all the animation modifiers that we apply to the feet. Sorry, that we apply to this animation. And here we have one for the left foot and one for the right foot that generates those curves. So basically, based on the movement of the speed of this joint, that's how we generate that curve. Next up is defining the radius and interpolation of your locking. But that we've bounded to a struct. So I'll just unbind them for now so you can see what they are. Expose and expose. And there you go, they're right here. You can choose what's my distance to ground threshold, what's my speed threshold, what kind of locking it is that I'm doing. Generally, when you're locking the foot, we found that it's better if you lock the front of the feet instead of the back, but you can actually lock the whole foot. You can choose to just not lock them at all. You can rotate around the back of the foot, or you can just lock the foot altogether, rotation included. If you have a bigger character, maybe locking rotation straight up is better. Next is the unplant radius. If you've seen in the recording, that's the, oh, my camera went over here. This radius that you see here is the threshold before we break that lock. That's all, those are all things that are user configurable. If you see that orange radius near the center, that's a replant radius. Basically, when the foot unlocks, the foot wants to relock. And when the foot relocks, it goes outside the red radius. Then it wants to get back to the, it springs back to the orange radius, and then it locks again. That's what that does. Then when it comes to slope alignment, those settings are here. Let me just look at the pelvis spring interpol. Yeah, right here, pelvis settings. So I saw that some people in the community were not really sure where, like this setting specifically, like the actor movement compensation mode. Generally, what this does is that it's very hard in games to have really smooth geometry all along. So what this will do is, as soon as you hit a geometry, like hard geometry, like imagine like a big box. So a good example of that would be these ones over here. The capsule, I'm going to do show collision right here. You'll see that the capsule like immediately pops up when I hit that, but you still want the feet to properly interpolate and the pelvis to not pop when I go up on this geometry. So sudden compensation, that's exactly what that does. It keeps the pelvis low while the capsule goes up. But depending on what kind of geometry you have in your game, like if you, my rule of thumb is if you have stairs that look like real stairs, then what you want to do is set this to component space. But if your stairs are actual ramp geometry, it's better to use sudden motion only. So that's it for the foot placement node. One more thing that I wanted to point out that Caleb will most likely not cover is that we've improved orientation warping to behave better whether you use alpha curves or not during pivots. That's thanks to prediction that we now use on orientation warping. Let me show a little bit of that. You were not going to talk about that one, right, Caleb?
I totally forgot we made that improvement. Yeah. But no, it's really helped with yeah, taking out a lot of the jitter that was on the orientation warping behavior. We still use alpha curves because it's not been perfected yet, but it'll give you more of like just a better out of the box behavior for orientation warping.
Yeah, exactly. All right, and then the last thing that I wanted to talk about today is of a cool feature that we did not have a chance to add to the sample in 5.5, but the feature is there, so that's why I wanted to go over it. Well, we have an example of it, but it's minimal, so I wanted to go over like the feature itself. It's called curve matching for motion matching. What that is that now the way motion matching works is that your database indexes features based on the pose of the character, like where the feet are, where the hands are, or what the trajectory of the root motion is. Curve matching allows you to do the same algorithm, but instead of matching the character's pose, you're matching arbitrary curves. And it's opening up. Here we go. When I say arbitrary curves, I mean user-generated curves like the ones you see here, or the foot speed curves and whatnot. So this facial animation that you see over here is an animation that I exported from the MetaHuman sample. I just brought it over to this. And I'm going to show you how to make a motion matching setup that allows you to search this whole animation. Like it's not raw mocap, but if you threw raw mocap generated from your facial animation video to capture and you generated curves, you could use something similar to this. So the curves that I'm going to be matching for this example are probably going to be, I think there was a good one for eye blinking, this one, and then another one for jaw open. Those are the curves that I'm going to be matching. So here we go. I duplicated the setup already, just in case I forget how to do certain steps, but I'm going to do it from scratch right now. So I'm going to create an animation blueprint. Oh my God, I forgot how to make animation blueprints.
Every time we make a new one, it's kind of like, how do we do this again? Like,
yeah, exactly. We do it so often. So it's gonna be that simple. I'm gonna create a motion matching node in this graph, plug it in, and now I need to create my schema and my post search database. Just call this one live stream schema. And for this one, I'm just going to delete the channels that are created out of the box, the trajectory and pose, and I'm going to be adding, one more step that I forgot about. You might have seen this if you looked into the traversal setup, that you can make blueprint extensions of channels. There's a new type that's called a post search feature channel curve. I'm going to create a child of that, post search channel livestream 2. And what this lets me do is the query is a quick summary of how motion matching works. There's a query that's basically what the game is requesting. There's the continuing pose, that's what the animation selection was already doing. What this lets you do is overwrite the query part of that of the game context by something that you provide through Blueprint. So here, instead of using the curve from the continuing pose, I'm going to be using a curve from the game context to my animation blueprint. Blueprint. Here, I'm going to be adding a map. This is going to be a mapping of my curve name to my desired value. I'm just going to call it curve map. So here, I'm just going to grab the curve map. I'm going to find the curve that corresponds to that value. This post search feature channel depends on the curve name that you want to index in your database. So I'm just going to plug that straight in. And that's it on the channel setup. Back to the schema, I will add a new channel that's the one I created right now. The curve name that I want to match is going to be one of these two. Let's start with jaw open. And curve name right here. And now this is where it gets, well, I need to create my post search database yet, so it's not interesting yet. Let's drag and drop that animation. And just to make sure that everything's there. Yeah, it's working just fine. And now the same curve name, I'm going to add it to that map I created in Blueprint. How do I do this? Here. Select the database, and a new feature that we added for some reason in 5.5. We had good reasons. It's a play rate multiplier. I'm going to make this animation not actually play. It's going to get stuck at whatever frame it's selected, just so it doesn't advance once it finds the curve value that I want.
And just to clarify, when we add things, they are for reasons, typically.
Uh-huh.
Although we don't always remember what they were.
Yeah, exactly.
There was a good reason at one point.
Yeah. So there you go. Give me an animation with the jaw open. Give me an animation with the jaw, a frame with the jaw closed. Give me one for the jaw semi-open. And now let's go in between with all of that like that.
Nice.
Now, a cool thing with this setup is that you might be thinking, oh, why don't I just use a morph target and I feed a jaw open? The cool thing here is that you can provide this raw mockup where you already have a physical performance of what you want that animation to look like. And instead of like trying to manually feed morph target or curve values that you think match like human facial animation, you just find me the best human facial animation that already exists in my data set. And the other nice thing that you can do with this is that you don't need to search just one curve. You can do more than one. So the second curve that I'm going to be using here is that blink one. So same as before, let's make another channel. New curve name, and we're going to make blinking be significantly less important to the search than jaw being open is. So let's give this like a 115. And now to my blueprint, I need to add the same thing. And let's start with both on 0. Okay, give me a frame that has the jaw open. There you go. Now give me a frame that's blinking and has the jaw open. You can see it didn't find one that had the jaw completely closed, probably because that doesn't exist in the animation that I gave it, but if you had more, it would most likely find that. Now give me one with the eyes open, but with the jaw closed, with the jaw in between. And you can just see that I could probably build an interesting facial animation system using curves and motion matching now. Now, why did we add curve matching to motion matching? The idea here, well, Caleb's the reason, because Caleb asked me, asked the team.
So for those curious, there is an example in the sample now. In the state machine setup, something that we wanted to do is use a lot less data. And to do that, we took out the 45s and the 135s from the animation set. But we ran into a problem when we're trying to match, say, like a run forward cycle with a run left cycle or a run right cycle, and that's the feet are moving in completely different directions. So when we're matching, position and velocity, we weren't getting good matches. So we decided, well, if we could use a curve and bake the curve to represent the phase of the animation and use motion matching to match against the curve, that would give us what we wanted. And so that's what we did. And that gave us, effectively a phase channel, which was really cool. But it can be used for, anything really. I mean, it's super flexible. Like Jose demonstrated, right? A conversation system using curves and motion matching can be done. But so that's the example that's in there now. So
to that point, the goal here is that at some point we actually have a channel for our schema that's called the phase channel. That's super experimental, but we didn't get the results that we wanted. And Caleb knew exactly what shape of curve he wanted. He's like, why can't I just match that? Right. And the idea here is that anything that you can come up that you can express as a curve in your animation, now it is something that you can match. I've heard of people do something similar for a crouch animation or an in-cover animation where you have portions of the animation that have the curve and other portions that don't. That's really up to you. Like go wild on what it is that you want to match with curve.
Right. So like, for instance, if you have like a tired run animation, you don't have to put that in a different database. You could have a curve that represents how tired you are. And you can just use that to drive selection. So, And
I heard you mention the multiplayer support, but you didn't show it, so
I
I'll
didn't
just-
know. You're right.
Yeah, so I'll show it really quickly, and then we can move on with our lives. So, oh, I still have debug on, so let me disable that. Let me just put this character in a nice vantage point. And there you go, networked. And I've seen some comments that, like with the community, that this does not perform very well in bad networks conditions. What we wanted to do was keep this example very simple. This is probably what some you're gonna be finding on, I wanna set up multiplayer in my game. Like this is the most dead simple version of this. And the idea of that sample is not to show you how to network your game, it's just to show you how
Well,
to...
the caveat to that is, obviously we want to show best practices.
Yeah.
With the character movement component, which we call the CMC. Networking is near impossible to do properly without code.
Yeah.
We want to keep this a blueprint-only project, and so that was the limitation there. But we do have plans to address this in the future, so we're not, going to write off multiplayer at all. We definitely want to support it the right way in the project. Can't say too much now, but stay tuned for the next update.
What we can tell you is that when we support good networking out of the box without code, that's when we will update the sample to do exactly that.
Exactly. Yep.
And that's it from me. Yeah. With that, let's hand it over to Tony, who made all these great animations that you're seeing here.
That physically hurts. So I quickly wanted to just talk about some of the things I've seen from the community and stuff about like, oh, I want to use motion matching, but I don't want to have 500 animations. And I feel that that's just kind of like a misconception of motion matching. You do not need 500 animations. We provided you with 500 animations because we wanted to have an example of everything that we could think of, because then you can kind of make your game for like what type of movement model you're using, what type of movement, like what is required for the game. So we were just like, okay, we have to have strafe, we have to have forward facing, we have to have as many examples of everything that we could think of, every permutation of an animation, because if you wanted a specific performance, I want the person to stumble when doing this, or pushing off the left foot, this person has a limp, I'm going to duck my shoulder into, like, this might be something that comes up in your game. So we're like, let's provide everything. But then I see people look at it and they're like, I need all of this. It's like, no, you don't. You don't need all of this. We just gave it to you so you can mess around, like turn stuff off, go into the database, shut down everything except for the loops. It actually works pretty well. There's a lot of good selection. You might see some more foot crashing, but then that becomes like, in your game, do you have a lot of these like snake motions or zigzags or pivots? Then add what pivots you need in. Do you have a lot of running backwards? Do you need a ton of backwards running animations? Maybe not. Take those out. When we added in walk was a very smaller subset than run. But now we've brought both walk and crouch up to the same set as run. So it just can work as like this blanket example of all of the different ways you can do stuff. And so you can just tailor make and just kind of learn from what we did there. And so that was the idea. But you do not need 500 animations in motion matching. You do not. Cool. And so if we can go over to my screen, I was going to show how, like when we were adding sprint, we had a smaller subset of animations.
If you want to go back to me real quick, I can demo exactly what animations we're going to be looking at.
I was going to show that, but go ahead, Kim.
Oh, I'm sorry. I just thought it'd be easier if we just, So
you already have it up, so do it.
So, as I said earlier, we added sprint, and as a part of that, we have these really nice sprint turns, and we didn't actually have data for these. We didn't have, when we did the mocap shoot, these were never shot, and I was talking to Tony, and I'm like, well, we need something there because it looks weird without. Can you do anything? And Tony, being the animation genius that he is, and he's going to show you exactly what he did. And I think, in my opinion, they're one of my favorite animations in the game because they're just so intense. And they give you these really nice turns. So yeah.
What I found is that Caleb likes when I make my animations that don't exist. So that's a good thing, because when I make something, he's not like, ugh. And so kind of another thing to think about for this is it's actually really hard to capture sprints, mainly because you're asking a person to do it. And so like using our, I just see a spinning U, using using just like our game as an example, or at the game animation samples, like the sprint is really fast. It's like kind of full bore going. It's like 7 meters a second. It's really fast. Asking somebody to then physically do that, you're risking knees blowing out, having a stuntman go careening across the mocap stage. Like it just like the danger level starts creeping up. So we had a lot of like running forward or sprinting forward, sprint stop, stuff like that. And we had like a couple of like run turns. So I was like, what happens if I take a turn, run turn, sprint start, cross blend between the two of them, animate on top of it? What do you get? And so this is an example of that, of what I did. So like here's animation. So it's him just running forward and digging in and sprinting. And so it's like, well, here's the requested turn, and clearly these are really far off. And see, like I don't even have to clean up how zigzaggy this is. Like he was already kind of drifting to the right and then coming back center. I'm like, huh, that's kind of close to what I wanted. So here's the requested, and there's like, what's this located? This actually, I dial back about 20% of it because it's not going to be moving the exact speed. So I need to have a little bit of kludgy room for foot placement and making sure that I can make this speed. And so what I do is I take the entire body and hash it off into basically these simple locators. So it basically has an origin locator, and then we have our just which way our feet are going. And then you can see this is the path of the feet and the running. And then I throw it on a layer. And the first thing I do is I take, you can see how this line goes from being that straight wobbly line to now it's affixed pretty closely to this curve. And so that is actually, I just went in and selected this file, and you can see like it's not a keyframe in every frame. It's just, here, stop showing everything, just show this. So you can see this is just me slowly affixing it to the run animation. And then I take this and just apply it to the feet and the run, and it's the same run animation. It's just now curving around. So now when you watch it going around, and he's actually digging in and making this turn, and it's like, okay, well, that's pretty cool. But if you look at it from perspective, he's sliding all over the place. So that foot hits and it slides out, and that foot hits and slides out. And I mean, especially on this turn, you can just see that his foot isn't planted. Now it's sliding all the way out. But with this, I can then start working on foot planting, which is like I have it affixed to the path, but now I can go into each foot, and then all I did is I just started removing data. It's like, here's right before it plants, and here's right before the toe lifts, and I just blow away all this data, and these are now the same key. So if we go into, see here, it's the exact same value. And so having this character relative animation that is now baked onto a layer, I can now figure out exactly using Maya's math where in space it is when it leaves, and then now the foot. Here, let me go to a perspective view so you can see. Now the foot is perfectly planted, and I haven't had to rekey or do any animation or anything on top of it. It's like I can just use the calculations to now have it planted in, we just added a whole nother rotation axis of problems than trying to plant the feet. But this is a really fast way. I did this in like 20 minutes, just replanting all the feet on each one of the kickoffs here. So now I have, and so I added a little like lean additive here as well, just to kind of like make him like lean further into it. But you can see it's like 4 keys. And from here, now all the feet are planting, like there's no foot sliding. Everything's like looking pretty cool. I can move on to retiming. So this is, I just flattened everything out. And so now just on the animation, he's just running around and doing that. And so now the problem you can see is this red one is the game's version of this turn, and then the yellow is, of course, the character is just the raw animation. You can see he gets really far behind. Here's my little 100, and here's where they actually cross. And so this is where I picked, like I just kind of went like 20% back to 100, and now I can retime this animation. And so you can do this kind of in anything. I'll just use Maya. So we can go to the ends, we can go down to here. This is my endpoint, so I can just quickly drag this to 100. And now you can see it's following better. It doesn't get as far off, but then you just pick this point where it's off, just grab it, start dragging it around to kind of retime it real fast. Just have to get in the ballpark. Oh, wrong direction. He needs to slow down. Here, slowing down. Yep, a lot closer. And you can see I'm just editing the entire animation. There we go, getting a lot closer. And so through here, I can just keep adding more of these all over the place, retiming them. You can actually like click and make them go away or bring them back. And then you can, if you've retimed something, you can then move it after the fact and then retime again. A lot faster. Then eventually, here's my retimed version. So now you can see that here's the red, here's one. They're kind of right on top of each other. There's this little back and forth wiggle. Totally fine. We want all those weight shifts. We want all this stuff from the mocap. It doesn't need to be like bog simple linear. It just needs to be close. And then the simple thing I can do is I can just take this. This has my my translation values, and I can just copy them. And then I can go over to my capsule motion now because the character is doing exactly what I want, and then paste it. And then now it's 100% 1-to-1. So now I know that the request, because I can see it, is exactly what the game wants to see. And then after all of this, jumping just real quick to the final animation. I'll drag this over, come here. All that same work, you can kind of see, here's the translation. I've stitched the sprint steps to the beginning. I've stitched the sprint steps to the end. And now you can see him, ooh, computer chugging. There it goes. There we go. So now you can see this has the pivot to the push off, and he's going around, and you can see the value there, and I can turn that off. And so, yeah, there we go. Not too long, and here we have a stitched in. Well, that didn't take that long.
No, not too long for Tony. That's because that's your.
Yeah.
You know.
Okay. I know this is like a lot of kind of high concept stuff, but it's so now we don't have to look at my screen anymore. Oh, we can go back, but
And that is true. Like it'll take him 20-30 minutes just to spit out a new animation that you could think was mocapped. It's like, what?
Yeah. So a lot of times Caleb will say like, "Where's this?" I'm like, "Oh, we don't have that." But I also like to capture as many things as possible, and mocap is just a tool. It's not a way to animate. It's just a tool. So then I'll just start grabbing things. I'll be like, "Oh, this is close to this, and this is close to this. Let me just grab this part, sand off these edges, cram them together, and then be like this." And then usually Caleb is just like, "Yeah, but," and then I go, "Oh, okay." And then, but it's more of like a performance thing. He's looking for something very specific, and I go, "Oh, yeah, I can do that too." And then we just, either I redo it if I was way off in my guess, or like we didn't have any walk turns, so all of the walk turns are all hand keyed. And
another thing was that there was we couldn't do a mocap shoot. There was a strike.
Yes.
So that was a
little
huge limiting factor on our ability to make new animations. Thankfully, we had Tony, so we were still able to do cool stuff.
I can cobble things together and luckily make them, I think, look pretty good and not have people even notice that I changed them. But yeah, so that was my work. I just want to show like kind of another update. I know I showed like the capsule relative motion, and so this is just kind of like adding a turn into that capsule relative motion, and it's kind of a fun way to animate and a way to like create things that never existed, not never existed, but never existed in your project. You can use the animations you have, and so just get creative with how you're using it. And we've gave you so many different parts and pieces. Just start chopping them up and using them for other things. I've already seen people like making attack animations from stuff that's really cool looking. So cool. And now I think we'll move on to Ludo, or Bluto from Labyrinth.
Yes. Okay. Let's talk a bit about cameras, gameplay cameras. So if all you're interested in are like animation curves and foot planting and all that jazz, you can go get a snack for 15 minutes or so. But if you're a cool person, you might want to stick around. So
and anybody who likes animation should also like cameras because they go hand in hand. So
I
say stick around.
It's the 3 C's, character,
right.
camera, controls. Okay, so yeah, we shipped a new thing called gameplay cameras in 5.5. So it's like if you go in plugins over there, you should have like these gameplay cameras. It's like this experimental. We mean that it's experimental. If we find some bugs in 3 minutes and it crashes, it's it's experimental. So but there's a lot of cool stuff coming in 5.6, so hopefully it's going to be in beta in 5.6. Anyway, so if we start this, so like Caleb said, like by default it is running the new camera system. So everything you see here is switching cameras and all that, that's the new camera system. The way it works is that, so if we go and open the character blueprint, there is this new gameplay camera component that runs a camera asset, this thing. Can't click on it because it's running, of course. It's this guy. And so the way it works is that you've got like a director, which here is set to a blueprint director. You've got a choice of different types of blueprint for the director, which is the thing that effectively orchestrates your different camera modes. So it's like your state machine or your switching logic, whatever you want to call it. And because people call it differently and want different things, out of the box, for example, we support like two things, blueprint and state tree. So you can use a state tree for a state machine between your different camera modes, or here it's a blueprint, it's this thing. And it's running like some logic that checks the character state and activates one or some other rig based on, actually it's over there, sorry. And it's activating like different camera rigs, we call them, depending on the state. And the camera rigs are over there in rigs, where you've got your different rigs. So each rig here, they're all using effectively the same rig under the hood. So it's like different presets over the same rig. That's the actual rig. And this is basically, running some offset, some rotation, some dampening, setting the field of view and all that. You can see it's like a graph, like everything in Unreal, where you've got those, like you see all of the nodes that come out of the box on the left here in the toolbox. One of the reasons it's experimental is because the choice here is fairly limited. It's just the basics, but again, there's going to be more later. And so that's what's happening here. Of course, I'm going to prove it to you by opening the camera debugger, because of course there is some debugging information here. So this is the hierarchy of camera nodes. So you can see, for example, here that it's running this balanced strafe camera rig, which runs an array of an offset, a boom arm, a dampen. So that's what we saw here effectively, right? These are those nodes running. And as you blend to another or blend over there, you can see that you've got blend stuff. You can this only shows you like the nodes. You can also look at the actual state of the camera. So for example, you can see that this balanced strafe rig is setting the location, the field of view, the focal length. Well, not the focal length, that's that -1. There's a bunch of other properties, like here the sensor size or the shutter speed or whatever, but I'm hiding those that aren't changed. And so here you can see how it's switching between all of those. So that's the system in a nutshell. We saw Rewind Debugger earlier. There is Rewind Debugger support, which is super cool, I think. So if you run around and you zoom and you do this and do that and whatnot, and then what do you need to do? I think you need to go like this. So you can rewind, but you can enable the debug information so that here now you can see the blending frame by frame. You can inspect everything, you know, you can look at your stuff, you can look at your node tree, look at your dampen nodes only, all that jazz. I think it's cool. Isn't it cool?
It is
Caleb?
cool.
Anyway, so this is, let's try to do something now. So I think I need to, what did I do? Oh, of course it crashed. Is that Rewind Debugger or is that my code? I don't know. Yes, I think it is crashing right now. I noticed that it happens sometimes when you exit Rewind Debugger. What is going on?
Shots fired.
No, it is not. Okay. Aha.
Aha.
Good.
It has recovered.
It has recovered. Oh no, it was frozen for a bit. Okay, so let's close this. So Caleb mentioned that there is the new sprint mode here, but it actually doesn't you know, change the camera mode. Like when you here, if you go in sprint mode, it stays in this like balanced strafe camera mode. So let's try to add something. Over there, this is the director, right? So we need to add something that says, if we're sprinting, let's go in sprint camera. So there is like some very beautifully laid out blueprint logic. Let's dirty that up with some horrible hard coding. So first, let's look at the class, like the actor in which these cameras run. Caleb set up like a nice little interface thing. We're gonna hard code it like barbarians by casting directly to the character type and, you know, asking for I think it's the input state. Yeah, and the whether oh no, I can't do that, of course. I need to break there. And so I've got my want to sprint here. And so here, if wants to sprint, I'm going to branch that over here. If I don't want to sprint, let's keep doing what we were doing and move all that ugly stuff here with like crossed wires. This is horrible. I love it. And if it is sprinting, let's activate another camera rig. There. Of course, we need to make a camera rig. So let's add over there a sprint camera rig. I think it was running balanced strafe before. So let's start with that. So which means that it's, you know, that same third-person camera rig as before, but with, you know, a set of overrides here, because that that camera rig is running. So again, that offset, rotation, dampen, but you know, it exposes the trend, like the translation offset of this offset. It exposes the dampen settings. It exposes the field of view, and so that's what you see over here. That they show up here as, you know, on this black box. Those are parameters that you can tweak. So let's start with the same settings, and then in the director, we can say we want to activate sprint. And I think it should do it. Let's see. Let's double check in there. Oh, let's remove the filter here. There. Now it goes to sprint and back to strafe. Okay, that's good. The reason it already blends between both is because all of those rigs here, you can set up transitions on them, like enter and exit transition, but you also have shared transitions here for all of the rigs in the asset. So by default, unless you specify a different transition on a particular rig, all of the rigs in that camera will use this 1 second smooth step blend. So that's why it already uses that. But now, and this is where it gets cool, is we are going to live tweak this because, of course, the camera system supports live tweaking. And let's look at the let's look at those overrides. Let's maybe make the field of view a bit wider. I don't know. And now when I sprint, I don't know if you can see it. I can make it bigger if you don't notice it. Like, you know, if I make it 120, then yeah, there you see it. That's a bit excessive. Let's move it back to, what was it, 95 or whatever. We can also jazz it up a bit by going back to the director. And here, because we're going to be tweaking blueprint, we need to stop pi. Let's add a little bit of stuff. So here I am going to get the player control, the player camera manager. And I am going to start a little camera shake that I prepared a bit earlier. It's a sprint camera shake. It's a normal camera shake. I mean, I'm hoping to add support for like a new fancier camera shake system in the gameplay camera plugin later, like for 5.7 or something. But right now you use the good old camera shake blueprint classes. So I added, like, you know, a little bit of shaking here with the purling noise. And what we're going to do is stop that shake when we get into that state. And on false, we are going to stop shakes of that type. I mean, that's not how you would actually do it, but that's a good, you know, hard-coded little shortcut. So let's make it that. So it should stop the camera shake when you go in it and stop the camera shake when you exit. What is this complaining about? Oh, yeah. Here. And now, when we go in sprint mode, there, you see this fun little thing. It looks fun. I like it. So it shakes a bit as you go in, and then it goes back to normal as you go to lock. So yeah, that's fun. Let's do another little fun thing, which is something that Caleb asked me to show because he liked it, I think. This course here, you know, when you go on it, of course, you do the, oh, now it's shaking all the time. Of course, you know, it's a third-person thingy. Oh, what did I do? Oh, I enabled some shaders. But we're going to add a little something. So we're going to add a trigger box over there. So let's make it big enough to encompass this whole thing. Where is it? Over there. Over there. Something like that. It's a bit too wide. Doesn't have to be that wide, but it has to be tall enough that we are going to be in it for the whole duration. And so the idea here is that, yeah, does that look good, guys? Yeah. The idea is that we're going to enable a different camera for going over this course. We're going to have like a little 2D camera on the side, because everybody knows going to 3D games was a mistake. The pinnacle of video games was 2D. So let's go back to that. Let's go. So we're gonna also add a camera. There is a new, just like there is the new gameplay camera component that we saw in the character. There is also an actor that also has that same component in there. Let's put it somewhere on the side. Oops. Somewhere there. And let's activate and deactivate when you go into there. Somewhere here. Where is my trigger box? Oh man, why does it hang up? Yeah, it's hanging up again. Oh. Oh. Oh, weird. So this is the trigger box. Yes, this is it. So let's add some on actor overlap and on actor and overlap. And let's add this camera actor. So we're gonna activate it when we go in over there. This is absolutely riveting, and deactivate it when we go out. And of course, we didn't set any camera asset on this, so we're gonna have to create a new camera asset. So let's go in there. So camera assets are in gameplay. Over there, we can use, so this is where you typically pick the director. Like I said, you've got the state tree, you got the blueprint. We're gonna use a single one, which means it's got no logic. It's gonna be just running one camera rig. So live stream, live, oh, live, wasn't sure. Live stream.
I don't know what it is with autosaves, but it always starts when you're renaming something. It's like a universal thing.
Yeah. And we are going to add a sequence like an offset, and we are going to attach to the player pawn. So here we can make this use the live stream cam, and theory, once we teleport over there, okay, so the camera is obviously attached to the to the pawn, but it's right on it. So let's make this smaller. Let's show a bit more of the pie window. So here the offset, how about we go back by, I don't know, 300 or something. Of course, that won't change anything because we're attaching after. So let's attach before and do the offset after. That's better. Where is my guy? Oh, I think my guy fell.
I think he went the wrong direction. You offset
Oh,
forward.
yeah, probably. Yeah, I need to go with negative offset. Yeah, that's the other course we're seeing here, right? There. So I don't know, minus 600. We can maybe even change the field of view a bit by adding something here that changes. Oh, that's too much. Anyway, you can like tweak this to your hot content. And now, oops, you've got a side scroller. However, you've got this problem where, you know, I'm trying to go left and right, and it actually goes left and right for the character. And this is because the like the game doesn't know about this change in control rotation thing, right? So it's like we don't want to rotate or control the character based on the character. We want just to control directly based on the camera. And right now, the way that this is handled directly in the blueprint. It's like there's a, if you look at yaw over there, it's running this classic thing which updates the controller pitch and yaw directly based on the input. But here, like, it doesn't know that we changed. So we are going to do a little, like, there's many ways to do this. Like, it's control rotation is a complicated topic, but there is one easy fix that is gonna help us here. In the project settings, you can tell the camera system, the gameplay camera system, to set the control rotation based on the resulting camera. So whatever the orientation of the camera is, it will set the control rotation to that. This, again, this isn't for all games, but that's going to work here. Let's also move this guy right here so it's faster to restart. And now I can go left and right on my little thing. So I can go, oh no. And well, when I fall, of course, since I exit the volume, then it will go back to the, I'm very bad at this. There. Oh my God. When I said that 2D games were the pinnacle of gaming, I didn't say I was good at them. So, and I missed the last jump. But anyway, so that's a cool thing you can do. One last thing I want to show is that, so this was, a workable camera. There's a couple of extra nodes that you can use, like, for example, if I go to this camera and I make it use another camera I made over there, this camera is using this dolly framing. So dolly framing is effectively just going to make the camera actor move sideways and up and down, like it as if it was on the rails, and try to frame the character in screen space instead of just like attaching using 3D transform. So we're gonna tweak a bit the there's an offset there. We're gonna tweak that a little bit. We can even get a bit closer. Okay, oops. And to show you how this works, let's re-enable the debugging. Oh, it's freezing again. I don't know what's causing that. Obviously, that didn't happen when I was rehearsing. I wonder if it's the streaming. Oh my God, it crashed. Oh no.
It's okay. It's live. I feel like it's inevitable every once in a while, right?
I said it was experimental the entire.
Exactly.
Your background's pretty good.
Oh, thank you. Yes.
Yeah, it's a nice background.
Good thing I've got some not something absolutely horrendous as my background, actually. Oh, can I recover all that? Sure.
You've recovered the crash.
I don't know what it's gonna recover. Someone had to crash and it was me. Good. But yeah, I mean, the dolly framing is going to work with the actually, did it recover it? No. It's going to.
I didn't see you hit save in a lot of things, so
Yeah,
whoops.
yeah, that's what you get. So yeah, oh, let's just show this. So this will effectively frame things based on the based on this those like screen space coordinates. And so the green zone is sort of like the dead zone. And oops, oh, of course I didn't re-enable. I don't think it saved that project setting that I changed. Or did it? Yeah, it did. Oh, I think I need to change the I need to change my there, yes. I need to click like the middle mouse button to go into I'm so bad. But now it will like have I think a little better framing. I don't know, the way it moves looks a little better to me because it's in screen space and it has like a screen space damping as opposed to world space damping. So anyway, that's it. And of course, yeah, I made it. Oh, this is amazing. Okay, and there goes back to normal 3D stuff, and that's the gameplay camera system.
Sweet.
That's pretty cool.
All right. So then at the end of this, I wanted to do a live demo as well, walking through the experimental state machine setup that we have in the project, explain a little bit about why it exists and how to build it from scratch. So if we want to get into that, yeah. So essentially, um, when I first started using motion matching, it was a very difficult transition because I'm used to having control over what animations are being played at any given time. And I know, community feedback, we've heard a lot of the same where, technical designers like myself, they just want to play animations when they want to play it. And motion matching can be kind of big and scary. And so I'm stubborn and I wanted to make a state machine system as well. Um, but Unreal sort of has some difficulties with state machines out of the box. And to have a little example, I just want to walk through real quick. So with Unreal state machines, they don't handle state reentry. In this example, we have two states, like a start state and a stop state. And let's say you're transitioning from the start to the stop, but then you want to transition from the stop back to the start. What happens? Well, in Unreal right now, you can't restart the start without popping because it still has weight. And so that introduces a lot of blending issues when trying to build state machines. With motion matching, we've introduced what's called a blend stack to Unreal. And a blend stack is essentially, under the hood, what would be happening with a state machine is rather than going from the start to the stop back to the same start, over here, this is what a blend stack does, where I'm going from a start to a stop. And if I go back to the same state, it essentially, it's a new instance of that animation. And so the concept of a blend stack is really, really powerful. It's necessary for motion matching. It's why motion matching can blend between a whole bunch of animations and restart the same animations without blending issues. And so like, here's an example of, a typical locomotion state machine. And you can imagine all the blending issues that might happen if you're blending between all these states and you're trying to restart states. And again, with a blend stack, that would all be solved. You can go from these states and restart states and not have to worry about, blending out of the state completely before you enter back in. And so, with the motion matching system, we actually have a blend stack now in the editor. If I open up an animation blueprint, I can show that to you. we have this node called a blend stack. But one of the limitations right now is that state machines don't use a blend stack under the hood. And actually, the motion matching node is itself a blend stack as well. And so if I double click on a blend stack node, we get an internal graph similar to the motion matching internal graph. And this is the experimental setup where I'm combining the two, but I'm going to just build that from scratch so it's sort of easier to understand. So let's say I want to use a state machine because I want to have control over what animations are being played. Maybe I only have 10 locomotion animations, and so I don't need motion matching necessarily. But I want to have the blending behavior of a blend stack. How can we combine these two things together? Now, a purpose of this exercise internally for me was, well, what could this look like if we had, a state machine that had a blend stack? And so this is heavily experimental, and we wanted to showcase this anyway, simply because it might be useful to users. So what I'm going to do is I'm going to create a state machine, and I'm just going to call this simple state machine. Oh, please don't crash. Oh, no.
Yes, I'm not the only one. Yeah.
I just did this, and it was okay. So
Is that a solidarity?
Yeah,
That's what we're going
solidarity
with.
for Ludo.
Thank you,
Yeah, yeah.
Caleb. I mean,
Solidarity
Tony
for
is
Ludo.
right. Caleb is really like the nicest guy ever.
Thanks.
Yes.
Well, hopefully we can do this demo.
I believe
Unlike
you.
Jose. Jose is an actual monster.
Everybody on the team is really nice.
well.
Let's just say that. All
His
right,
headphones
all
are
right,
monsters.
Let's redo
Yeah.
this.
Yeah, I know. It's his headphones
Yeah.
for multiple people.
All right. Okay. Please don't crash.
You actually can hear like 15 minutes into the future with those.
And 27 miles away.
Oh my god.
Simple state machine. Is it the name? It's causing me to crash? No, there we go. All right. Blend stack. All right, where was I? All right, so I've got a state machine and I got a blend stack. Now, the way a blend stack works is over here in the details panel, you see I've got a lot of stuff, and I've got an animation asset reference. I've got properties with that animation. And anytime that animation asset reference changes, a new blend is triggered in the blend stack, and it changes to whatever the new animation is. And so if I were to expose a lot of these properties, the animation time is simply like the start time of the new animation that's coming in. Let's see, blend time, profile. All right, so I've got these properties exposed. Anytime these properties change, a new animation is added to the stack. What I've done is I've created a struct. Let me find it here, just called blend stack inputs. And if I split this struct pin and feed this into the blend stack node, I think I did that correctly. Essentially, what this would do is anytime I make a change to the struct, let's say in the event graph, if I wanted to set the sequence reference of that, of the animation pin, the blend stack would trigger a new blend. But like I said, we want to use a state machine to control the blend stack. So how do we do that? Well, inside of a state machine, or actually inside of any animation node, we have these things called anim node functions. And these are functions that get bound to the animation node. So when an animation node evaluates, these functions execute as well. And inside of a state machine, if I were to create a new state, I'm just going to call this idle. If I can type. If I double click on this and click on the output animation pose node, you can see that I've got functions that I can bind related to when this state enters or when it exits. And so if I create a binding here, and it's just going to call it on state entry, and I'm going to say on state entry idle, this function will execute when that idle state enters. So what I could do is I could take this blend stack inputs and I could set what that blend stack is going to play using that struct. Like let's say an idle animation. idle loop, stand idle loop. And I want this to loop, so I'm going to check loop. And I want to give it a blend time, so I'll just do 0.3 and compile that. Alrighty, if I go back to the animation graph. Well, now I've got a little bit of an issue. So I've got my state machine, which I'm sort of treating as a state controller now, and I've got a blend stack. How can I execute the state machine, but take the pose of the blend stack? The next thing I can do is I can take a two-way blend node, hook these both together, take the pose 100% from the blend stack, and now on this node, we have a little option here to always update children. And that means regardless of the weight of the state machine, its logic will execute. And so then I'm just going to override this so I can demo this simple state machine. Because if you disconnect parts of the graph that have anim node references, it likes to yell at you. So that's a problem. So you have to do a blend by bool there. Cool. The last thing I'm going to do ahead of time actually is copy over some steering logic into the blend stack node. Like the motion matching node that has all of these, orientation warping and steering, etc. And we went over that in our first live stream back in the summer. The blend stack node is the same way. So I'm going to just quickly copy over some steering behavior into this blend stack node. That way we won't see issues later on. And then this is going to need a different reference here because I need to take the input from this node. So if I call this, I click on this node here, and then in the tag section, call this, let's say, simple stack input, I can get that as an anim node reference, which means I can get the animation that it's playing, and I can get the time of it, and I can use that to drive the steering logic. Cool. So let me just see if this is actually working. Great. So now I've got a character. Now foot planting is keeping the character falling behind. So as Rudolph said, I'm going to turn that off. Now I've just got the character in an idle animation. But we want to do more. So let's say I want to add some basic locomotion animations to the state machine. And you'll see why a blend stack is so powerful in a minute, but I just have to set this up first. So let's add some states. Let's say start, loop, and stop. And then start adding some transition logic to it as well. Just a super simple state machine here. So if I am idle, if I start moving, we have this function in the sample already called isMoving, and that checks the velocity and the acceleration. Go to locomotion. If I am not moving, go back to the stop state, the idle state. And then same thing here. I've got to copy this. I could use aliases as well, but to keep this simple, I'm just going to duplicate logic here. Alrighty. Now, the next thing I want to do is set up sort of an automatic transition rule. Now, one of the issues with having the blend stack separate, I mean, obviously it's a very experimental thing, and we want to make this better in the future. But we can't use the automatic rule based on animation time remaining, because the animation is effectively not even in the blend stack anymore. Or sorry, the animation is not in the state machine anymore. If we add a tag to this node here, the blend stack, I'm going to call it blend, simple blend stack. Then I can grab that node and then convert it to a blend stack node, which is similar to the cast. And then I can get the time remaining directly from that blend stack. And then if that is less than, let's say, 0.3 seconds, then I also want to check if that's not a looping animation. Come on. Please work. No, it's going to throw an error. For some reason, sometimes using animated references in state machine transitions throws an error, but that's okay because I'm just going to collapse this to a function, and I'm going to call this function is blend stack anim almost finished. And I should do that anyway. That way I can reuse it. It's going to be pure. It's going to be thread safe. Great. And that should work. I'm going to copy that also from the transition to the stop to the idle. Okay. Then the last thing I want to do is I want to, again, control the blend stack with these states. So similar to the idle, I am going to make new anim node functions and hook them up to these nodes here. And I'm just going to copy it to save time here. So on state entry start, on state entry loop, and on state entry stop. And then in the, in the start, I want to hook up on state entry start. In the loop, I want to hook up on state entry loop. I promise this gets exciting in a second. At least it should. All right, so I've got those. Or wait, no, did I just do the wrong one? I did. Okay, that's the stop. Okay, so now I've got functions set up that can select animations when these states enter. So for the start, I want to pick, let's say, a run forward start L foot. Come on, there we go. That's not a looping animation. I want to start it at the beginning, and I want to give it, the blend time of 0.3. That works. For the loop, this is going to be a run forward loop. Okay. And then for the stop, this is going to be a run stop forward, what I think would be a good one. Now for the stop, I know it's going to have a different start time. So if I click on this animation, I'm going to say, hey, I want to start this animation at 0.75. So back here for the start time, I'm going to say 0.75. Compile, save. And hopefully, fingers crossed here, if I were to play the game, you can see that I've got a character that's using transition animations, and it's being controlled by a state machine, but all the blending is happening through a blend stack. And I've already messed it up there. Look at that. I have this set to loop, which means it'll keep going. So I'm going to turn that off there. And just to demo this even more, and we're going to escalate this. We're going to take this further because we can introduce choosers here, and hopefully you can see how powerful this setup can become. If I debug here, there we go. I've got a state machine, and now I can make really fast transitions. This is where it gets really exciting. I can blend from the start to the stop to the start to the stop really, really quickly. And because I'm using a blend stack under the hood, I don't get those blending errors that it would if I was just using the state machine tools. But like I said, we can take this further. One of the things that's happening right now is we don't have syncing between the start and the loop animation. Now, traditionally, you could use sync markers, but that could be a pain to set up. But what we can do, if we open up this on-state entry loop, is we can use motion matching, actually, to choose the start time of the run animation. I'm going to make this bigger just so it's easier. So if I have a motion matching function in here, I can take its result and use it to drive the animation that's being selected here. I have to cast to, so there's a difference in, this takes in an animation asset object reference, motion matching outputs an animation object reference. We just do a cast to animation asset. Cool. And then the output of the motion matching node, we can use, hey, drive the start time. Yeah. So for the anim instance, I'm just going to self. And then the assets to search. I just want to search against one asset right now, and that's the run forward loop. And the reason this works, and the reason I can do a motion match on this animation, is because similar to the traversal system, if I open up this animation, here we go. Let's open up here. I've added a pose search branch in tag to this section of the animation, which pretty much tells motion matching, these are the frames I want to motion match against. And this is set up with a database, which has a schema, which lets me say what's important with this animation that I want to match against. But essentially now, if this works, fingers crossed, no crashes, now I'm using motion matching to transition, or I was. Okay, here. What happened here? Oh, the pose history. I didn't fill that in. So the pose history, we're going to give it the name of the pose history node in the graph, which is just pose history. And you can see that this will work here. Okay, there we go. I was in the wrong rotation mode, which is why it looked bad. But now we're using motion matching to blend from that start transition to the cycle. Now we can take it a step further. One of the things that I like to do is I like to keep selection logic apart from the state machine logic. So a start could be a lot of things, right? It could be a start to the left, it could be a start to the right. And I don't really want to create a whole bunch of states that are like, this is the state for starting to the left, or this is the state that's starting to the right. So how can we make this clean and easy? Well, right in here, I could select different animations in different ways. And the best way to do that right now is using a chooser. So I'm going to make a chooser real quick. That's going to allow me to select different start animations based on the different angles of locomotion. And hopefully it won't take too long. Chooser table. This is just going to be a generic chooser, object of type animation asset. Okay, create. I'm going to call this. Okay, see, did it automatically save there when I was naming it? The same thing that happened to you. I knew it. Simple demo, I don't know. Or you know what, simple starts, that'll be good. All right, so I've got this chooser table. Now I want to set up this chooser to take in data from my animation blueprint. And the way I can do that is I can add a class parameter, class being, oops, did I type it wrong? Okay. Oh, it just doesn't want the space bar there. Anim sandbox. Nope, I did it wrong again. Sandbox character, I'm sorry. So I'm going to use this as an input, which means parameters from the animation blueprint can drive selection in the chooser. Okay, so if I add a row here, I'm going to add a couple rows. Actually, no, I'll just start with one because I can duplicate them. This is going to be my run, start, forward, left foot. Is that the animation I wanted?
That's a animation.
That is a animation. Neutral, run, start, forward, left foot. There we go. And the column is I'm going to use a float range. Now I've already got a parameter in the animation blueprint, which describes the difference between where I want to be rotating versus where I'm rotated right now. And that's called target rotation delta. And I'm going to just set up some ranges real quick. So if I start moving forward, I want to play the forward start animation. But if I start moving in other directions, I want to play other animations. And we have refacing start animations. Run, reface, start, L90. There we go. This is the power of good naming conventions too, because you can find things pretty easily.
Wow.
That's right. Thanks to Tony.
Tony fought hard for that one.
I fought hard for my naming conventions that group together and truncate, and
Yeah.
noticed you say
now,
truncating properly all the time.
Yeah. So I can set up ranges real quick. Maybe I should have duplicated these. So forward, left 180, which means I can in this angle range, choose this animation. This will be the, hold on, let me duplicate here and do the right 90. All right, and then the right 180. Oh, So 45 degrees to 135 degrees, and then 135 degrees to 180. Again, fingers crossed, live demos, stuff can happen. Oops, I have to actually evaluate this chooser. That's easy enough. Evaluate chooser. And we're going to choose the chooser that we just made, which is simple start. Now it's already going to input this. I mean, this could be self, but I think if you leave it blank, it should get the right thing. The result is an animation object reference. And so we're going to input that right into the animation that we want to play. Compile, save, and we should see some differences. Yeah, check that out. So now, as you can see, we can scale up our locomotion behaviors very, very easily by combining all these things together. And you can see if I put the chooser there, if I've got the animation blueprint down here, we can play this live and see the debugging happen. If I scroll out here. All right, so I've got my state machine down there. You can see when it goes into the start state, it actually is using the chooser to select a start animation. And based on the angle, we get different animations playing. Hopefully that's cool. I think this is cool.
Caleb, I'm curious how this looks with only the 90s or only the 180s.
Well, we could we could see. Choosers are great because you can edit them live. And what we can do is we can disable rows really easily. Just going to disable these and then change these ranges. And now for the 180s, it's using the 90s. And you might not like that, no big deal. I'm just going to go back. But you have a lot of freedom here to do exactly what you need. I think we could take out the 90s and only have the 180s, and that could probably work. If I take out the 90s, just disable those. So now it's going to use the forward start. If I increase this range, yeah, it'll use the forward start animation for the 90s and the forward, and then it'll still use the 180 start for these. There we go. Now I want to take it one step further, if that's okay. I don't know how we're doing on time. We're going pretty long. Tina, let me know.
No, you're good. We can be here as long as y'all want to be here for it.
We'll do one more thing because I think this is where it really gets interesting.
How long the audience wants to stick around for?
Right. I don't know how many are left. Right. How many are watching? Did I bore everybody?
How many dozens of people are we still talking to?
Right. Okay. So for our stops, let's do something a little bit different but similar. For our stop animations, right now we're only selecting one. But let's say that we have a left foot and a right foot version of a stop animation, which we do.
We do?
How would I select that, right? Well, I know, well, it's the same angle, okay? So if I use angle, it's not really going to give me what I want. Can't really use speed as a condition because you're running at the same speed, but I can use motion matching, and I can do a pose match based on what foot is forward. Choosers allow you to do something quite fun, which is not only output one animation or one thing, but output multiple things. And I'm going to demo that really, really quickly. So I'm going to duplicate this, and I should be saving. Save all command. Where did the save all? Oh, there it is. Okay, we're going to call this simple stop. And in this chooser table, we've already set this up. But we are going to just have, we don't even need that column. Run, stop, forward, left foot. Here we go. Duplicate it, Control D, run, stop, forward, right foot. And maybe I want to use the chooser because I want to differentiate, based on speed or whatnot. But right now, I'm just going to keep these two stop animations in there. I go back to the animation blueprint, and I'm going to evaluate this chooser. And it's going to be simple stop. Okay, great. if I click on this chooser node, you'll notice here, there's two different modes. I can either output the first result that is true or all results that are true. And if it's all results, it gives us an array of animations. Now you'll remember, if I go back to the loop function, when we're doing a motion match here, well, we can take in a whole bunch of animations. And that's exactly what we're going to do. I'm going to copy this node, and I'm going to go back to, oops, went back too far, back to the stop function. So when the stop enters, this function will evaluate. And I'm going to do a motion match on all the animations that are true on the chooser to pick what stop animation to play. And ask to anim asset as well. I'm going to try to keep it pretty clean, unlike Ludo, whose blueprints were a mess, but that's okay. And then the selected time, we're going to put into the start time. And I think that's enough. I compile save. Now we should see that when we're doing a stop animation, we're picking a different stop animation based on which foot is forward. Look at that. So that's the left foot forward. That's the right foot forward, left foot again. And so combining these different tools allows us to just have a lot of control over what animations are playing, use motion matching where we want to use motion matching, get the blending behavior of a blend stack. And the last thing I want to showcase as well, something with choosers, is choosers can also output additional data along with the object that they output. So if I were to click on this chooser again and open this up, our simple starts, I can add a struct here, or a struct parameter. I'm going to set this as an output struct. And I've already made the struct, but you could make your own blueprint struct, and it's called chooser outputs, I believe. There we go. And so if I add a output struct column, bind this to the struct parameter that I just created, when I click on these rows here, I can essentially configure or just send out additional data with the animation that gets selected. And you can see here I've created a struct that gives me a start time, uses a blend time, etc. So if I wanted a really long blend time on my forward start animation and a really short blend time on my 180s, if I just do this and then go back to my animation blueprint, you'll see that it outputs a struct along with my data. If I break this struct, I can feed that directly into the blend stack so that I can change the, or I could also, I could do the start time and the blend time of whatever is set in the struct in that chooser. So now if we see, when I start forward, I have a really slow blend, okay? And if I go backward, I have a really fast blend. Now, the one caveat here, and this will be fixed in a future engine release, is that this doesn't work well when we're outputting multiple things, because it'll output an array of results for the object that the chooser is, but it won't output an array of structs. It'll only output the first thing that it finds. That is a known limitation of choosers, but we're going to get that fixed. So just keep that in mind if the struct and the animation that's being output maybe don't match up after like a motion match or something like that. But what you saw just here, this setup, is essentially identical to the experimental setup up here that's shipped in the update. I'm going to re-enable this. I might just say goodbye to that. Oh, come on. What's it doing? Oh, yeah. Okay. So if we open up this, effectively we have the same thing. We've got our idle loop, we've got our locomotion loop, we've got our stop and our start. And you're saying, well, these aren't stops and starts, they're transitions. And that's true because, in my opinion, a start animation is the same as a animation like a walk to a run. It's just a transition. You have things that take you to loops. I should probably do a better job explaining this, but it's a way to sort of condense state machines a little bit so that you don't have too many states. And so let me just do this live again so that we can see the full character with the state machine set up. So I've got my transitions and my stops, and it's all being controlled through a state machine, and all of the states look at a chooser to pick what animation should be playing and then perform a motion match when needed. And all of this, I have a lot of comments in there which should hopefully walk people through what's going on. So if we open this up, we can see I have a generic function in there to look at a blend or look at a chooser to pick an animation from a blend stack, and that's all commented out. But the principle is exactly what I showed you just earlier, where we're just combining a blend stack and a chooser and motion matching where we need it to, and we can get some really powerful. It gives us a lot of control, essentially. And as a designer, I like that. All the things that we can do with motion matching, we can still do with a state machine setup. Doing our shuffle animations, our refacing start animations. It's all there. I think that's about it, honestly. To touch a little bit on what I mean by these transitions, if you were to take a state machine and break it down simply, there are two kinds of animations that are going to be playing. There's loops, and then there's transitions to loops. So if you have a start state or a transition from a walk to run or a pivot animation, all of those animations are transitioning from something to a loop. And that's the way that the state machine is structured. And the transition logic is such that if like the gait changes, if I'm walking and I start running, or if I start to pivot, or if I go from standing to crouch, I'll go back to my transition animation, and then the transition can take me to the loop. There's some additional stuff in there, like if the chooser doesn't find an animation, I should probably demo this. If the chooser doesn't find an animation, it can just skip the transition entirely and take you right to the loop animation. And that allows you to scale your data really well as well. So yeah, I guess we can just move on to Q&A now, because I know I took a lot of time. But that's a breakdown of the experimental setup.
Very awesome. Very cool. You all showed some really awesome, incredible updates to the project. And don't be sorry for taking the time, because that's exactly what we're all here for. I don't know if any of you had the chats pulled open, but when you were like, should I keep going? Everyone was going, yes,
Okay.
don't stop.
That's good.
Yeah, so
I probably
no
missed some
worries
stuff in
there.
there too that I
I was just having headphone conversation on the chat. That was it.
Important
You can never get away
conversations
from
are
us
happening.
derailing conversations behind your back, Caleb.
Oh my gosh. All right. So we do have quite a few questions. Just for the sake of not keeping you all hostage on stream for the next several hours, I'm gonna weed them down a little bit, combine some of them, and paraphrase some others. So if you asked a question and you're like, my question wasn't answered, it is, but I'm condensing and paraphrasing a little. So if it's not worded exactly how you did, don't worry. The sentiment is here, and it will
It's
happen.
Tina's
I
fault.
promise. Yes, just blame me. All right. So first question I've got here for y'all is someone was wondering if you make pure functions and then use them in multiple places, do they get processed multiple times as well?
I guess I'll answer that one. Yes, they will get called multiple times, as they would be if you had them in code. If you want to optimize this, you could probably cache the result of one of those in your event graph. But then you run into the issue of like, hey, if my state machine just happened not call this, you're gonna call it anyway. In my experience, like calling a a pure function in Blueprint, at least in animation land, it's less of an issue. Like if you were to like ship this project and you nativized it, even if you're calling this pure function multiple times, you'd probably be okay. So my answer to these in general is like do whatever most comfortable for you that makes your workflow the easiest. And when it's time to look at performance profile, use Unreal Insights, see if that's actually your bottleneck. Likely your bottleneck is going to be somewhere else.
Awesome. Wonderful. Next question I've got here for y'all. Also, I feel like I should state, I am having so many technical issues today, so I'm reading your questions from a separate screen. So whenever I look down, I don't want anyone to be like, what is happening? It's the questions are here. So anyway, moving on. Next question for y'all is, would the state machine setup be better for setting up a more momentum-based movement system? And the example they give is running uninterrupted increases speed over time.
It's a tricky one. I think both.
Yeah.
It really depends. There's a lot of factors in that. If you want to have a blend space between like a slow run and a fast run, that could be done in sort of a state machine setup. I don't have a blend space example with the blend stack. Perhaps in a future release we could do that. It could also be done with motion matching though as well, because we support blend spaces in motion matching. And so
it's kind of how you push your velocity, and then you could use motion matching to transition between the animations, or it could be in the state. It's kind of taster's choice. It's how you want to control the animations, how you want them to play, and how you want that timer to work.
Which I know isn't much of it. You might be looking for a more direct answer, but it is. There's a lot of factors involved. I mean, how much? No, go ahead.
I can do my attempt at a direct answer here. I'll say that blend stack state machine versus motion matching is less about momentum and more about control.
Yeah.
Blend space motion matching single animation is bad for intermediate states, whereas blend spaces are really good for that. So I think that what you're looking for here, the answer is blend spaces. And we didn't showcase that we have improvements in 5.5 for blend space support in motion matching. But maybe, do you think I should show that, Caleb? Like the new things with blend spaces?
Let's wait until we have an actual example.
Okay, yeah. But play around with it. It's way better now.
Got to give people a reason to come back next time.
Yeah.
Exactly.
Yeah.
See, I'm just hearing that there's a promise of a next time now. So this is basically legally binding, I'm just saying.
No. Uh-oh. The contract, the blood pact is sealed.
The verbal handshake, it happened. Somebody clip it. Next question that I've got here for y'all is, are movement analysis functions bound to trajectory instead of CMS? And is this, if so, how it's generally done with motion matching?
That's a good question. It is a mix of both. If you want to share my screen real quick, I could just show what the trajectory analysis or the movement analysis functions are. So essentially in the motion matching setup and in the chooser setup as well, and I might as well just open up that the chooser of the experimental state machine, because I realized I haven't shown that yet. All right, so this is a big happy chooser, which contains all of the animations in the experimental setup. And we're using nested choosers here to categorize animations. So if I open up my, let's say my runs and my run forward animations, we can see some bools here. Some of these are what we call in the animation blueprint movement analysis functions. One of them is pivoting, right? So if I open up my is pivoting function, this just is true when I determine if the character is pivoting. And it can be a lot of different, we can look at a lot of different things. Sometimes we're looking at the trajectory, and other times we're just looking like, do you have movement input or not? So in the motion matching condition for is pivoting, I'm getting the angle between the future trajectory velocity and my current velocity. And you can see the current velocity is actually taken from the CMC. The future velocity is taken from the trajectory. And then I'm doing, well, if my rotation modes are different, a different angle threshold on them. So yeah, it's a mix. It's really whatever is needed. Sometimes the trajectory will give you the information you need, and sometimes you just want directly from the CMC, hey, do you have input acceleration applied? And so, yeah. Movement analysis, I mean, it's not a super fancy thing. It's just little bits of information that allow you to control the animation in different ways. Like the is moving one, for example, is a good one. And I realized that I've completely forgotten to attach the velocity from the is in the is moving function. But again, if I have a future velocity and I have an acceleration, I must be wanting to move. So that's going to be true. And that's a mix of taking something from the trajectory and also taking something right from the CMC. So it's a mix.
One thing I'd like to add to that, Caleb, is that I would strongly recommend that even if you're not using motion matching, having trajectory is good. Like if you look at Lyra content sample, how we detect pivots is you look at last frame versus next frame, but last frame and current frame is completely different at 30 frames per second than it is at 300 frames per second.
Yeah.
Versus if you have a trajectory and you can tweak the values to make it more performant, 0.1 second ago versus 0.1 second in the future is going to be significantly more consistent at variable frame rate.
Right. And so in the experimental setup, we're using pretty much the same data that we were using to control the motion matching selection, at least at a higher level, all of the choosers in the motion matching setup. We're using that same data to control the state machine selection as well. So yeah, if you're just making a state machine, totally use a trajectory. It can give you a lot of really good information. And then in the future, and we don't have this yet, but when we do things like collision prediction, like you're gonna hit a wall in a second or two, we can use that same data to drive selection again, regardless of state machine or motion matching. So I hope I didn't leak anything there, but yes, we want better collision prediction. That's something that we want to do.
Yep.
Very cool. Awesome. Next question here is about gameplay cameras. They're wondering, can you animate the gameplay parameters to create something super dynamic instead of just transitioning between predefined camera rigs?
Yes, in 5.5 that is pretty limited. It's one of the reasons why it's experimental. So yeah, there are support for like camera variables and those things that I was actually let me am I still sharing? I think so. So if you look at stuff like this, like where is it? This guy. So all of those parameters that are exposed here, you can derive them dynamically with set camera rig parameters, and then you can select something like sandbox or like one of those. I don't think any of those expose any pins though. Well, expose any parameters, but with this you can derive those, like the pins would appear here, and you can set them all. But it's fairly limited. I actually just finished a big pass on making that much better for 5.6, so it will be much more powerful in 5.6. But in 5.5, that's the only thing you have. But yes.
Very cool. There's a follow-up camera question as well here. Is there a way to set view target with blend to a gameplay camera from a normal camera? They're saying that currently they can only call active camera, which seems to snap their view.
Not quite sure about the last bit, but so in 5.5, the way it works under the hood really is that if you look at the not the plugins, if you look at the project settings and you go down to gameplay cameras, it's got this thing here that's auto spawns the camera system actor. Because really what happens under the hood is that what it does is the first time a gameplay camera component will activate, it will auto spawn one of those little guys. Actually, if I stop playing, you will see it in here in the world outliner. This guy. So it's yellow to show that it's dynamically spawned. So what it does is that it auto spawns that thing and sets that as the view target. And at this point, the view target is the camera system, and everything blends inside it. And the game doesn't, like, for the game, it's just a big black box that just shows the result. So at this point, if you set the view target, it will blend away from the camera system, and then you can blend back to it. There are, I think, if I remember correctly, there are some global blueprint methods that you can get to get this automatically spawned actor. You can also just add it in your level and not having automatically spawned so that you can control it better. But so yeah, calling set view target will effectively move you away from the camera system and then back into it if you set back to this actor. So so you can do that. That's also a thing that I'm working on for 5.6 and 5.7, especially because like for a proper usage of the camera system, you actually don't want that to live in an actor that is a view target. You want to make the camera system live in the camera manager, the player camera manager. And then at that point, set view target gets called on it, and the camera system would be able to handle that better. But that's using this system actor is a nice way to just get things working without having to, fiddle with the game mode and override the player controller class to override the player camera manager class and all that. So this is just a quick way to easily prototype. I hope I answered the question. I'm not sure, but hopefully I did.
Yeah, seems good to me. Next question we've got here is the root data from current take recorder good enough to start matching my CMC while waiting for the new tool?
I'll take that. Yeah, 99% of our animations are from Take Recorder. It gets close enough. It does have some weirdness when you're using Take Recorder, so there is some vibration if you lose frame rate or if you're not at a consistent frame rate. And there's some parameters you can set where you try and like lock your frame rate and stuff like that. But originally, we just captured everything with a input blueprint and Take Recorder, and that's how we got like 99% of our capsule data. It's close enough. Like when there's those weirdnesses, you can just smooth it out because the actual data is within inches. So it's not exact, and I don't know how much I can say about the new tool. The new tool is exact because we wanted to get rid of any of those limitations and make it a lot more user-friendly because it would be a tool. But just using the Take Recorder right now gets you close enough for government work.
One extra thing in there is that your frame rate being consistent is important for your recording. So what we usually do internally is on project settings, we set the project to fixed frame rate to like 30 or 60 frames per second, and we capture like that when we want to capture the exact game trajectory. Or you can lock your frame rate if you're very confident that you'll never go under X. That's also good.
Yeah, like we tried just locking frame rate. We tried a bunch of different ones than just would kind of Pepsi challenge the different angles, and they were always super close. They were never super off. But so we wanted to get the consistency, and we have that, and that's coming. But just right now, the Take Recorder does just fine.
Awesome. Next question here. So I'm combining, there were quite a few questions about stairs. And I'm going to kind of combine all of them down into a couple. The first is based off of the foot movement that you showed kind of near the beginning of the stream. They're wondering if this also supports movement and animations on stairs.
I can take that one. So stairs are a very hard problem in games. Most games don't solve it very well. Like my recommendation is that if you have like stair-like geometry, set it to component space and it will be kind of okay. If you have ramp-like geometry for your stairs, set it to sudden move only and have like simple collision for the capsule and complex collision for the stairs. Now, when it comes to motion matching and foot placement, we are not actively working on it, but it's on our plan in the future. One is to improve foot placement to be like the best stair solution. Like we've talked internally over how we would do it. There's good research papers on how to do that out there. Foot placement doesn't do that just now, but that's something we want to do at some point in the future. No promises on timeline there. Now, in regards to motion matching, there is nothing stopping you from adding 3D animations on your PostSearch database so you can match slope and whatnot. But like we mentioned before, the discrete states, it's good when you pick an animation, but not for the in-betweens, and your slope might be 45 degrees or it might be like 22 degrees, and then it gets weird, like you're on flat animation until you reach slope and then you suddenly pop. So maybe a blend space is better there. Like that's something that we are most likely going to look into in the future. But there's a bug right now with trajectory that the path of trajectory behaves really poorly when you're going up terrain. So if on 5.5 you want to use 3D slope animations with motion matching, you'll most likely have to roll out your own trajectory calculation, which is not very difficult. The code is simple, but it will require C++ to do that.
And just speaking from the animation side, stairs can be a rabbit hole because picture, those 500 animations we have for run. As soon as you start tilting up and tilting down, multiply those by 4. So now you're in the thousands of animations if you're trying to do like fully animated. So it just becomes like how important are stairs to your game? Like if you're making a game just about like running on a Stairmaster, then yeah, maybe you want to spend 1,200 animations on the like best motion match stairs that have ever existed. But we're going to try and find something that's a little bit more friendly and looks good without being the Stairmaster 9000 animation engine.
So stairs is on the list. I just want to,
yes,
make that clear. We want to get really nice slope and stair behavior. Again, there was a strike. We couldn't do new mocap shoots. We only had one Tony. So, yeah, incredibly complex problem. But yeah, we want to solve it too. So.
Yeah, sometimes it's throw animation at the problem, but for stairs, it becomes like you could, but you have to make sure because your memory budget and your animators are going to explode into a fine mist of different angles and step variation. And is there a landing to another step? It just becomes this monstrous thing.
Just pull the camera in so you don't see the feet.
That's what 99% of AAA does.
That's
right?
99% of AAA games will just be like, 2 animations and pull the camera super close.
Oh no, we're pulling back the curtain now.
Oh no.
I feel like the only other thing I've heard that is as difficult with stairs is maybe ladders. So
Doors, yeah.
Doors.
Ladders is actually easier than stairs, but still very difficult. Because you're essentially in a completely different movement mode. You can only go up and down. You can't traverse a ladder diagonally. You know what I mean?
You can't.
Stairs, you can kind of go diagonally upward.
Nobody. Well, I mean, maybe some people go up ladders sideways, but it's exactly that. It's basically you're going up or down the ladder, and then it's kind of entry and exit, and so it just becomes like, how do you get on the ladder? How do you get off the ladder?
The challenge is more in like the movement mode, the interaction between you and a prop.
Camera transitions, because like ladders love to break the 180 rule constantly. So it's how can you nicely get on a ladder without either your character going out of the camera or you have to whip the camera around 180 degrees and not make people throw up. Like there's
and also people want to look up or down, and then you get gimbal lock problems.
Exactly, you have the lookout problems. But doors, if you have, because then you have the left side, the right side, the door handle, the contact points, how do you open a door and get through? And pretty much anyone when they're playing a video game that wants to get through the door right away, but there's enough videos of people running into doors because you can't open them fast enough. Like, then what do you do for that? What happens when you're when you're smushing yourself up against a door and you also want to open it and go through without looking like a psychopath, like it becomes an animation challenge to make things not look ridiculous. Yeah.
See,
Don't
that's
have
why
doors, don't have
3D was a
stairs.
mistake. We should go back to 2D. That's what I say.
Yeah. Ludo's thing is just like
Yeah.
that's
Oh
why like a
my
lot of
God.
people they'll just like door hinges will go one way, but in video game land, door hinges go both ways. It's just like that's not how doors work. But once you start compounding all these problems, it's a nightmare.
So what I'm hearing is that the absolute nightmare mode of a game would be just going from stairs to a door that goes to the next set of stairs and so on and so forth.
It's the traditional like horror game
Make a
problem.
movie
It's just like
at that
if you
point,
have to,
you know?
if you have to open a door
What do
to
you
go
do in making a
downstairs into
game?
a basement, then yeah,
A game where all the doors open to the inside. That would be it.
they always open towards the player.
Yeah.
Amazing. All right, the last question that I'm gonna have for y'all today, and this seems mostly for those who may just be kind of new to the game animation sample project in general, not necessarily just the new updates. But there's been a couple questions about, are these usable in their own projects?
Yes.
Yes.
Yep. Free.
There you
For
go.
better
Go
or for
forth.
worse,
Mhm.
go for it.
Yeah. I mean,
This is our hope, really, with this project is that you learn from this project, and you can use your own animations, a mix and match of things. I mean, it's an educational project. If you wanted to make a project where people just run around and jump on platforms, as people have done, you could do it. You know.
If you want to have Tony's signature flipperoo parkour move, then
Right.
go ahead, right?
It's legal. You can
Yeah.
make an asset
Yep.
flip. But yeah, no, take these animations out of the project, right? Use them in another project. Use these concepts however you want. And again, this project is not the only way to do things. This is our way of doing things using the tools that we have, and also trying to drive future tool development by experimenting with things and showing them when they're still experimental. That's something that we like to do because we get more
Yeah.
feedback and get in people's hands. So
I
Yeah.
talk to animators all the time about extracting root motion and how you do that for a game versus how you do it for everything else because it's a whole thing and I have my way of doing it that I like and I think it gets good results, but even on the team we talk about it's like, okay, should the root be here or here, here or here, here or here, and sometimes it becomes a feel thing and it's just this is the version that we like, but look at it because it's done in a particular way and figure out if that works for you or if you want to change it. You might like a different way.
Awesome. All right. Well, I think that's going to be all the questions I throw y'all's way today. So I don't keep you here for too long. But of course, if there are questions that y'all have that didn't get a chance to get answered, make sure you post them on our forums and stuff like that so we can collect them and move them along to the teams that need to see them. But with that, first and foremost, I want to say a big, huge thank you to our wonderful guests for taking the time to be here today and to walk through all these cool new updates with the Game Animation Sample Project. I'm really excited to see what y'all continue to bring in the future because every time you come on, I'm blown away by what has been added, and it sounds like it's only going up from here. So really
More
excited to see what
stuff.
the future holds.
the
It is,
plan
like-
the plan of record is every engine update we want to have a good update to the project as well. Can't say what
Yes.
that's going to be.
Yeah.
But yeah, this is going to grow over time, for sure.
That's really, really exciting. So very excited to see what comes next. And yeah, thank you so much for taking the time. And thank you everybody who came to watch a show and be part of it and ask questions. It wouldn't be what it is without you and your interaction and you using the projects and experimenting around with them and playing with the tools that are provided to you. So thank you for being here and being part of the community and doing all the cool stuff that you do. If anybody happened to pop in partway through the show and you missed maybe the beginning of it or sections, no worries, because we post all of our streams in video format that can be viewed on demand on both our Twitch and YouTube channel at Unreal Engine. You can also follow us at Unreal Engine on all socials to keep up with the latest news, updates, all that kind of good stuff. And if you haven't already, I highly encourage you to go join us on the Epic Developer Community, which is where we host our forums, tutorials, learning paths. Our documentation now is also there as well. Pretty much anything you need related to the engine is available on the Epic developer community. So go check that out in case you weren't aware. It's a good time. It's a good place. It's a good time. Fun times all around. But I think
And
that's
you can
everything.
easily fast forward through my section to get to the far more entertaining Ludo section.
No,
Wait, no,
you
I
have to
mirrored.
watch Tony's section at half speed. It's
Oh,
required.
If we have to listen to Tony all day, you have to listen to Tony all day.
With that,
I am everywhere. I am Legion.
yes, Tony everywhere all the time.
All the
Thank
time.
you so much. Thank you so much, everyone.
thanks for
and
having
that'll
us.
be it.
Thank you very
Yeah,
much.
Yes, thank you
of
very much
course.
for setting aside the time for us.
Yeah,
All right.
and you have to come back for the next one. Like we said, there was a verbal handshake. It happened. I don't make the rules.
The pact has been sealed.
All right.
Actually,
well, thank
gonna
you so much,
slowly get
everybody.
bigger and bigger headphones for Jose.
Yes,
Oh.
each time.
They will get smaller for the next one.
Oh,
Ooh.
they're gonna get oh, bummer! I was hoping to just get like
Up and down.
yeah.
It's an emotional roller coaster. You
Yes.
know, we're here for the ups and the downs. But yeah, thanks so much, everybody, for coming. Next week, we're going to have on a couple folks who are going to be talking about Unreal Fellowship and what you can do to join those, how to get involved with stuff like that. So if you have questions about that or want to see how that works out, make sure you come back next week, Thursday at 2 p.m. Eastern, as always. But that's it for now. Thanks so much, everybody. Thank you again to our guests, and we'll see you all later. Bye, everyone.
Bye.
Bye.